Good morning, everyone, and thank you so much for joining today's webinar, Innovations in Affordable Housing via Mass Timber PH Construction. My name is Claire Hepburn, and I'm the Deputy Registrar at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide a space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I'd like to share some important information to ensure an effective and professional webinar experience. Please be informed that the session is being recorded for quality and educational purposes. To maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. We would really encourage you to engage through our Q&A window. So please feel free to submit any questions that you may have for our speakers. These questions will primarily be addressed in the designated question and answer period at the end of the presentation. And note that the chat function will be deactivated following these instructions. And for those of you today who are seeking continuing education learning hours, please note that your attendance is crucial. So you will need to attend for a minimum of 80% of the webinar to ensure that those hours are accredited to your OAA transcript. And just allow for a few weeks of processing and reporting of these hours. And then finally, note that our presenters today do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. For accessibility, we provide automated closed captioning services available in multiple languages to accommodate the needs of our diverse audience. And now I am excited to introduce today's session. Please welcome today's speakers, Matt Bolen, Morgan Wright, and Christina Boyer. Matt, over to you.
Great. Thank you very much, Claire. Great intro. And of course, I've got my team here that if we need to have any technical issues, if people can't hear me, then I'm sure someone will jump in. It's a real pleasure to be here today, especially talking amongst your peers who we all have so much respect for. It's a really exciting, a little bit stressful, nerve-wracking opportunity to get up and do these sorts of things. But we do feel it's really important and very much a privilege to do so. So we're excited about that and excited to jump in. We have come up with what we think is a very cheeky title here in our massive passive, and obviously that is going to be specifically featuring our work in both mass timber construction and passive house design and certification. So. Just to kick it off here, I am Matt Bolen, Managing Principal at mcCallumSather. I'm also an architect and have gone through my passive house certification, albeit a number of years ago. Morgan Wright is also going to be joining us on the call. Morgan is an associate here at mcCallumSather, as well as the project architect who has been working on a lot of our mass timber projects, specifically those with rapid housing and some of those first introductory pioneering projects. That really helped us break through, and so she'll be speaking to that specifically and some of that experience, both in terms of the delivery methods and some technical items with the mass timber. Christina Boyer, who's the passive house certified designer that you all want to be really leaning on here, is an architect here at mcCallumSather, but also again brings a lot of passion, enthusiasm, and expertise in terms of her passive house designer hat. And so at the portion that she's going to take on, she'll be able to speak to those things. And I'm sure if there's any Q&A at the end, she'll also be able to weigh in there. So just nice to obviously step back and give everyone a sense of what we're here to do today. It is a nice session. We're not going to try to rush it. We're not going to try to overwhelm with too much information. But really the structure of how we want to go through this presentation. And I have to say, it's really nice having done a similar webinar to this in the past and done various speaking engagements when you're just solo, but particularly solo on a webinar. it can be really challenging. And Claire mentioned the Q&A, feature that we have to this technology. We're really excited about that, and excited specifically that there's going to be 3 of us to be able to try and track that. That being said, we didn't want to have a scenario where we were sort of jumping on top of each other and creating any confusion. So we have tried to create a nice clean structure for today's talk around myself giving a bit of a background to our experience and how we're approaching this at a bit of a broader, higher level on our organization. Then we're going to go into Morgan specifically talking about mass timber and the delivery and execution and some of our, again, experience and understanding and expertise we've built there. Then we're going to move on into the passive house, the process and performance aspects of that, which again, Christina is going to take the lead on. And then I'm just going to close us out and bookend all the meat, right? And all the expertise is going to be in those 2. And I'll just try to do my best to bookend each of them with, again, where we came from and now where we're going with our future opportunities. So hopefully that makes sense. And hopefully all of you are going to get something out of it. We appreciate, and we've tried to tailor this presentation for those who maybe have very little to no experience or exposure to either mass timber or passive house design. And we're also sure that there's going to be a lot of you on this call that have tons of expertise and experience, and in some cases probably even more than us. So again, we're excited to present what we've done and the work we've been doing over the years, but just as excited for the engagement piece with all of you after. So I just want to start out with mcCallumSather. We always start with this, even in our own internal all-staff meetings. We like to go back to our mission, which is to be innovators of sustainable design and collaborative construction. Our vision is to have built environments that respect our earth, and our values are innovation, collaboration, respect, ambition, fun, and trust. And so hopefully, particularly with our values, you're going to see some of that sprinkled through this entire presentation. We shorthand call those our iCraft values, just simple acronym, and helps it create it sticky for us. But there are really words that we do try to live by on a daily basis, and it make this place, this organization that we've built and are building, a really great place, and hopefully a place that not only the people that work here, but also the people that work with us and align with us can feel that and feel that engagement. So again, just a little bit of the high level of who we are. So we are a firm with technically now 4 locations in Hamilton, 1 here in Kitchener, and the 3 of us, Morgan, Christina, and myself, are working here out of Kitchener right now. We have a small office in Kincardine as well as a small office in Toronto, and that's been really exciting as we've been building that over the years. The associate memberships we have, obviously, and it needs to be put out front and center. OAA, that's our primary. We do most of our work here in Ontario, and given that this is an OAA webinar, shout out to OAA for all the wonderful work and support they do with and for us. We're also, involved very much with the REIC, the national body, and we also do have various people in our organization licensed in the AIBC as well as in Nova Scotia and New Brunswick. Speaking to that, one of the reasons that we're building out a bit of a national approach and strategy here isn't to be a big fish and to try to grow into some sort of large consultancy. Where we really find ourselves at our core is in the value of delivering, and trying to go after that mission and vision that I introduced with, but doing it in a way knowing that we don't have all of the answers and all the understanding and expertise. So this is a small list here of our collaborative relationships and joint ventures that we're either actively working on or have worked on with other firms, across the country. We're very excited, very proud of these relationships that we've built and fostered, and are definitely looking to do more. So again, another reason why this is a really exciting opportunity to speak here at this webinar today, is because we can hopefully create and foster more of these discussions. And what we find is that when we can create these, I'll call it open source type of conversations with our peers, with our fellow architects. Now, I'm not even talking about the wonderful consultants that we work with, the clients, the municipal governments, the the regulatory bodies, all those things are great, and we value those relationships too, but we also deeply value the collaborative nature that we can have with our fellow designers, architects. And that's a big part of who we are and who we intend to be. So we intend to continue to build and develop those relationships into the future. And on that note, I should note that, you know, we do have these different offices, and you know, the Kitchener office specifically came from, well, my origins and background in Edge Architects. Some of you might have seen me do a presentation a couple of years ago in this forum. It was, you know, under the Edge Architects banner, which is again now come together with mcCallumSather, as well as Studio Canoe, which is the basis of our Toronto office. So that's not a plan to take over. It is just the nature of how we found these collaborative relationships can really prove to be fruitful over time. And we're excited about the different ways that understanding, not just of technologies, building systems, sustainability methods, all of those things, but the actual understanding of a place and understanding the vernacular, understanding the people in the place and the climatic issues that affect a place can just foster a much better design and better execution of built form. So speaking to, again, who we are specifically, we do a lot of different types of work in the communities within which we're a part of, but a focus of mine, as well as Morgan and Christina here today, and various others in our group, is around housing. And specifically, how we look at housing is through this diagram. It's present, obviously, in a lot of documentation from CMHC and other sources, but we do describe it as the housing continuum of need. And we feel like this is a very effective diagram at explaining that to people. And it's something we're constantly coming back to. And really what our goal is, and this has been informed over years of working with some really great groups, both in the private sector delivery of housing, market rate, but also in the supportive services of housing. We've worked with some wonderful groups there, and just generally affordable housing. That what we find is we want to deliver housing solutions because obviously we all know that it's a huge need. But also we want those solutions to be adaptable and inclusive. We don't want to have one type of building solution for one group, let's say emergency shelters or transitionary housing, that then is stigmatized as only being for them or only working for them or low costs, so that it doesn't, you know, apply to everybody else. We are actively looking for building solutions that can actually be adapted across that entire continuum, because that, in our belief, creates actually the truest embodiment of inclusivity in our communities and equity in our communities. When, of course, you know, a market rate higher end project can do things to elevate itself, swell out floor plates, add nicer finishes, or do different things. But if we can come up with repeatable systems and delivery models of built materials and panelization and all of these great innovative things that we're passionate about, and then apply them across this spectrum and this need, we feel that's going to create better results for all of us. And so we've been very fortunate over the last number of years to be really making some good inroads there. And as you can see, you know, as we make these connections, these are an assortment of just a few, both built and projects that are currently in design. And so again, there's a lot of excitement for us and pride that not only we have, but that all of the different groups and collaborators that we work with get to see actually coming to fruition here across, again, shelters, transitional housing, supportive housing, community housing, affordable housing, and market rate. So when it comes to low carbon and high performance design, again, stemming back to our mission and vision, that's always been a key part of who we are. Joanne McCallum, who many of you probably are familiar with, started mcCallumSather in Hamilton, you know, back in the 80s, and in Steeltown, trying to drive a sustainability. You know, she was talking about that, and the organization was talking about those things back then, when no one else was, and when a lot of people didn't really want to hear or entertain it. And that drive and that willingness to focus on, you know, the world we're living in and how to protect it and sustain it over the long term is really a core part of who we are. And there's a lot of different ways we can do that, but two that we're really trying to drive on and understand as deeply as we can is in low carbon and in high performance. So obviously the diagram on the left that we're going to get into once Christina starts talking about passive house strategies, that's something that we're into. We're into that. We're into net zero design and all sorts of different decarbonization with active technologies, but also at a more essential level and core or even grassroots level. We're wanting to make sure we understand, well, what is the value to low carbon? And when we talk about mass timber, we don't just want to be, using it because it's a buzzword or it's something new or fancy, or, someone saw it on a cool website from Austria, which, by the way, was where I first saw it, 15, 20 years ago. But that being said, we've tried to really ingrain ourselves in the actual delivery model and that full cycle of what that low carbon actually means. And so we also have a few slides here and images of recent tours we were able to do up into the Ontario forestry industry, actually getting out to see what types of tree there are. The picture on the bottom left there of me is me trying to figure out what tree is what. I think I took about 12 guesses and got it wrong every single time. So I haven't quite perfected that yet, but I am learning. And again, we even then got into the actual production facilities and the mills and just understood with these expertise of these foresters and how these forests are maintained and how we're changing the way that they're maintained and feeding, what comes out of them into our building industry. It's just for us a really important part of what we're doing on the sort of end user side that helps, really make sure that's a robust delivery of that low carbon solution. So I want to go now just at a bit of a high level, and for some of you maybe that might have seen a presentation I've done in the past, this is a little bit of a repeat period. I'll try to go over it pretty quick because I know we probably all want to get to the real meat of what Morgan and Christina are going to talk about. But I do, just particularly for those who aren't sure where to start, how do I start working with mass timber? That is the place that we found ourselves in about almost, probably over 10 years ago, but definitely back in 2017. We had one specific project here, and there was a couple subsequent afterwards that you can see where we knew we were passionate about and interested in about mass timber. We wanted to find out ways of how we could get it delivered. And these three projects are all projects that did not execute mass timber. And so I do just want to talk about them and talk about how having an interest, having a drive to do something, it does take time to push through. And so when we talk about our pursuits into whether it be mass timber, passive house, I mean, I was certified passive house 10 years ago, and we're working on our first passive house certified projects now. It does take time, it takes patience, but it takes consistent drive and sort of knocking on the door. We talk a lot about the importance for us about in the building industry, which is so rich and so complex, such big investments that people are making and such robust networks of people involved in their delivery and execution. It's really important for us to understand the conventional delivery of construction and why it's done the way it's done. And within that understanding, and as we've built our expertise and understanding in delivering conventional, we can actually look for the moments and opportunities when we can infuse that sustainable, again, low carbon, high performance innovation into that conventional process. So just to start out, we had a project in Kitchener, infill residential, right in our wheelhouse of where we wanted to really be delivering that missing middle in the housing need. We had it got whittled down to 2 different structural systems on that project back in 2017. We were featuring and talking about the brand potential and sustainability, which are, of course, big things that us as architects and designers always like to screen from the rooftops. But unfortunately, at that given time, there was too much uncertainty around cost, too much uncertainty around supply chain resources, and just general discomfort in fear of the unknown, which, again, was a good understanding of us to have. Next, we go to another project, which was a large, you can see the black building was an infill site. And in Kitchener at the time, office market was really booming. There's obviously the robust tech and financial services industries here and insurance. So the need and the desire for this Class A brick and beam office space with all these adaptive use projects that were happening was really, at its climax. So this particular infill project, which did include a mix of uses of high-rise residential and wanted to be, again, this brick and beam office, we had been talking about it so much, the mass timber, that a client group came to us and said, well, we'd really like you to explore this here on this site, which we did do. Now, unfortunately, on that project, the nature of the market shifted, and the nature of this project before the market shift happened changed as well. The project actually expanded to include the heritage building on the corner. That inherently expanded the scope of this office mixed-use development. And therefore, we found ourselves in a state where the mass timber, again, because we were going up and over this building, just wasn't a proven enough method and didn't check enough of the boxes in terms of the decision making for us to go that way. So again, instead of getting what we wanted to be, which was this beautiful mass timber structure building that, you know, various have now been built since in parts, you know, around the world, but North America, Toronto, various other places. Instead, we got this, which we're still very happy and proud of, and the client, you know, was really excited about. But again, it was a shift where we weren't able to see that execution of the mass timber on this project. The last one that I'm going to feature, and then I'm going to hand it off to Morgan, was a project, it was literally called Wooden. Like, I mean, come on, this was a no-brainer. It was back in, 2027, 28. We worked with NRCan. We had the funding all lined up. We were fortunate enough to use some of that funding for R&D to work with, at the time, Element 5, who was just starting up with a small research facility before they built their large state-of-the-art facility. We really got the ball going. We made tons of different connections. We tested mock-ups, both for qualitative and quantitative data. We were right there at the finish line. And of course, as some of us remember, the month we were supposed to break ground in March of 2020 coincided with a slight change in the way that that office delivery was happening. So for a spec office building, obviously COVID and the pandemic changed and put the brakes on that given project. That being said, we still had all of this knowledge, not only, as I say, about mass timber on the left with, you know, our mock-ups and all these networks and all this great engineering and code consultants and all these, you know, this great network and understanding we had built was still there. It was still alive, and we recognized that. We also coupled that with different innovations we were doing. We were doing at the time working with volumetric modular providers. We were fortunate enough to do with some really great not-for-profits, supportive services groups, do some prototype projects for them to help create some infill on their lots at a time when that really wasn't happening the way it is today. So we were excited to take and leverage that. And then again, we also had what you see on the right side is conventional stick-framed townhouse and mid-rise apartment buildings. We were working on those as well, all at the same time, down to even the one in the bottom right, which was an affordable housing project that ran through, you know, all this, the CMHC co-investment fund funding. We got that knowledge. This was it was a construction management delivery. So we worked there and we're building that comfort in that trusted system. And even with a product that wasn't inherently low carbon. It was, you know, ICF and still high performing and done to a high quality and robustness for the client, but not necessarily checking all the boxes that we had. And all of that data, that network, that experience, we used and we continued to keep leveraging until we were ultimately able to deliver and execute mass timber. So with that, I want to pass it over to Morgan, who's going to talk a little bit about that process. Okay.
Great. Thank you, Matt. Great introduction. Sorry, I'm just... Oh, there we go. Okay, great. So I'm going to talk a little bit more about mass timber, the CMHC's Rapid Housing Initiative, and then how we approached an architect-initiated design build project. So in 2017, Matt talked a little bit about kind of our projects that we were working on and how we had responded to one of NRCan's green constructions through Wood Grant during that Wooden project. So this research and development led to collaborations with different cities, stakeholders, clients. It really helped us get to know a lot of industry partners in the mass timber world. And it really gave rise to the use and adoption of these locally manufactured engineered wood systems here in Ontario, as well as just generally Canada. So we worked closely with our structural engineer and local manufacturer to kind of look at the design templates and really try to optimize a floor span and vertical circulation cores made from mass timber that we could then implement in our projects. Part and parcel to research and design was also finding opportunities to implement those designs. So that optimal range of CLT floor panels are adaptable in the building structure and can be used to create these flexible unit layouts. We focused on kind of doing a pre-design, having things ready to go, so that when we we're getting projects, we could kind of go from that 3-bed to studio and include barrier-free designs, and we had those templates kind of available to us. So we really focused on using a grid and kind of adapting to buildings of all sizes. So the controlled environment of that offsite manufacturing minimizes that on-site construction time. So allowing structural systems to be assembled is in as little as 20 working days. So over the course of this presentation, we're really going to dive into that layered approach in those collaborations in mass timber, whilst kind of targeting certification and novel methods in meeting those accelerated schedules. So here you can see kind of some of the different opportunities with the different structural systems going from a four-story, 2-story, 6-story, and kind of using that same optimal building span system. So with rapid and affordable housing at the forefront, we have really evolved our approach for mass timber housing. We've incrementally kind of advanced each prototype, changing just one variable with every iteration and evolving through each build. So leveraging that recent success in mass timber projects through speed and scalability, Passive House has become kind of our next lever to pull on. The evolution of a 6-story mass timber passive house really demonstrates construction efficiencies for prefabrication and its compatibility with these kind of high performance enclosures. So I'm going to talk a little bit about our housing strategy. This initiative was really started by a small group of industry experts who wanted to look at, as Matt mentioned, ways to destigmatize affordable housing. And then again, that greater arc was that we were all really interested in mass timber, and we believed it would really offer an affordable and innovative solution to that current housing crisis. So this is a site photo of 2 projects that we did in mass timber, the YWKW1 and the YWKW2. So these were preemptive projects to the 6-story mass timber project that we're going to dive into more. But I just want to talk about this for a little bit. Akin to that GC Wood Grant, the initial investment in housing solutions have been funded primarily through CMHC, and this provided an incentive and an appetite to build with mass timber. So these were some of those earlier iterations of rapid housing funding being used. And again, these projects really focused on that fast track delivery for affordable housing. So I'm going to show a little bit of a time lapse. So again, this is the image that was just shown. So the 1470 block line YWKW project, and this was used, mass timber was used as the structural system. So I think it gives a good sense of just how quickly mass timber can come up on site and how quick the structural system comes together. So this was 20 working days. Sorry, Matt, can you just go, oh, there we go, okay. So I'm going to talk a little bit about that rapid housing initiative. So that first project was done with funds from CMHC's rapid housing initiative. And after that project was completed, it was really exciting to see the federal government announce a second round of RHI funding at the 1470 block line project. They announced an additional $2 billion to build another 20,000 homes across Canada. So this, created the springboard for our client of the 1620 housing project, City Housing Hamilton, runway to pursue innovations in mass timber for the first time. CHH's journey really highlights the critical role of those reoccurring partnerships and pushing high performance projects as part of their mandate. And we were really thrilled to join forces with them in supporting that vision. Once built, the 1620 project is in the running to be one of the first mass timber passive house multi-res projects in North America, so we're really excited about that. Though modest in form, we believe 1620 redefines the possibilities for affordable housing in terms of delivery and quality of living. So I'm going to jump into our architect-led design build structure. So the funding we pursued allowed us and our mass timber partner, Element 5, to really kind of build out a dream team of experts to execute this vision. We brought in Malul Blamey, who is a well-known contractor, into the fold, and they were really essential to executing a project like this because they had the knowledge, the expertise, trade relations, and an incredible reputation. They were also really eager to try something new, and were also interested in providing really good quality housing for our community on that fast-track timeline. So you can see this is how the whole team comes together. Of course, many of you as architects probably know what a design build structure looks like. And though this may be conventional, I'd really like to stress how everyone on this team comes to the table aligned on the goals of the project, and there is a real collaborative spirit and problem-solving mindset. Similar to IPD, critical trades are brought into the fold at the beginning, and they're able to provide that input and advice for practical application of design ideas. And they're really able to provide that crucial information in developing sequencing and timelines for these really fast-tracked projects. So this snapshot here shows our project timeline at a high level. I would like to highlight that right from the RFP process, there was a mechanical review and an assembly review that pushed the team to make decisions really early on in the project. So once enough information was gathered in kind of a design charrette, the construction team was able to tender the project. Sorry, I'm trying to go back a slide. I think we went over that too fast. There we go. So once all that information was gathered in that early kind of design charrette, our contractor was able to create a fixed price. And right from the signing of the CCDC contract, we then moved into design development. At this point, we were able to get really down into the nitty-gritty as we moved into construction documentation. Having our mechanical contractor and our mass timber manufacturer on the team, we were able to coordinate all of the kind of the mass timber penetrations and work through a lot of design intent and manufacturing goals so that this effort could kind of streamline construction. And by the time we got to the end of the drawing phase, we were in a really good spot to start manufacturing the panels. This effort streamlines construction and really aligns with those passive house milestones as it minimizes the on-site modification. All of the work is done upfront in the process to ensure when construction starts, things can move really quickly and everyone's aligned on the intent. So I mentioned that we used Element 5 in a design assist capacity, which gave them the ability to do fabrication drawings and engineering at the same time. So we're able to, again, start that panel fabrication as soon as we receive our building permit. So it's beneficial to have this prefabrication that can happen because, of course, again, it means less site on time, and that when things show up to site, they can kind of just be assembled into place. So you can see here, this is one of the first panels going onto site at level 1. So just some quick facts about the 1620 project. We have our roof assembly, which is a 2-ply mod bit with mineral wool, polyiso, and then the 175 CLT panel. Then we also have a wall assembly, our typical wall assembly, which is the 105 CLT panel with the 8 inches of mineral wool, a Cascadia thermal clip holding up an Apollic fire rated panel. For the foundation, we just have a very simple concrete foundation with rigid XPS foam. And then again, talking a little bit more about the mass timber components and how that prefabrication really allows us precise control over the thermal breaks in the envelope, and was really gave us the control to kind of focus on those exact window size openings that meet the manufacturer's tolerances. I think here our window manufacturer specified 3/8 of an inch, so we were able to exactly CNC to that spec, and then it really offered great precision down to the millimeter. We had great air tightness testing results here because again we just had such a minimal bridge that we were able to really highly control. And then this here is kind of the current site work of the project. Again, we've got a video. Through kind of bi-weekly site visits, we were able to really witness the rapid pace of the CLT installation. In May, basement walls and ground floor panels were installed, and then by June, level 3 was complete. We were up to, level 3. It's kind of interesting because this is on a site where two projects were being built at the same time. And so it's kind of cool to see just the rapidness of that CLT as they're building the structure in the back. In July, we had our exterior panels of the 4th, along with window installation and the application of our weather-resistant barrier going on. And then by mid-September, we were able to complete our air tightness layer, and we were able to do our mid-construction air tightness test. And with that, kind of hoping giving a big rundown of the approach we've taken, I'll pass it off to Christina, and she can dive a little bit more into the nuts and bolts of the passive house performance.
Awesome, thanks, Morgan. So in this portion, I will focus on how the combination of mass timber and passive house design elements create opportunities to redefine possibilities for affordable housing, both in terms of building delivery and quality of living for its inhabitants. First, I'll discuss best practices through the 5 passive house design principles, and second, with rapid affordable housing at the forefront, I will discuss our process for design, build, construction in mass timber housing. So for context, City Housing Hamilton, our client, their mission is to create accessible, safe, and inclusive housing solutions. As the largest social housing provider in the city, CHH provides homes that are well-maintained and affordable. CHH continues to pursue passive house design for its desirable outcomes. This framework produces durable buildings for increased occupant comfort and to de-risk the delivery for their housing solutions. So as I said before, over the next few slides, I will briefly discuss how we implemented each of these principles onto 1620 Main Street East: air tightness, thermal insulation, and thermal bridge-free design, high performance windows, and ventilation with heat recovery. And then in the second half, I'll discuss our process. In each space, we highlight the structure. Partially exposed CLT ceiling panels are typical for each suite, and in shared spaces such as corridors, stairs, and amenity spaces. Part of CHH's ethos in championing passive house design is for both new construction and existing retrofits. In addition, they have a vision for legacy-inspired mixed-use developments through innovative construction methods such as panelized systems and quality of space for its end users. As Morgan had mentioned earlier, the Rapid Housing Initiative provided City Housing Hamilton runway to pursue innovations in mass timber for the first time. We were thrilled to join forces to support their vision. Leveraging recent success in multiple mass timber projects through speed and scalability, passive house became our most recent lever to pull on. The building enclosure performance targets were identified during the RFP stage and set the basis for design. The nature of design assist for mass timber prefabrication dovetails well into planning for passive house certification. As you can see, our typical wall assembly proposed during the RFP stage remained quite similar to issue for construction. The continuous substrate in mass timber panels are inherently airtight. In addition, these panels provide a seamless plane for continuous outboard insulation held in place with thermal bridge-free cladding clips. This evolution to a six-story mass timber passive house demonstrates construction efficiencies for prefabrication and, in addition, compatibility with high-performance building enclosures. Earlier slides, we diagrammed the architect-led design build delivery process, but in reality, integrated collaboration looks more like a flywheel effect for mass timber construction. To stay the course and synchronize performance goals with the design assist for prefabrication, RDH provided early and frequent building enclosure feedback. These feedback loops connected contractor to architect and consultants, but also between trade and engineer, and internally at RDH and on the architectural team. For example, RDH provided us the tools to pre-screen submittal packages so that I, as our in-house passive house designer, could bridge the CA process and review before passing along to Morgan, the project architect, for approval. The flywheel effect also incorporated construction schedule feedback from RDH to contractor. They made recommendations for sequencing and identified milestones for site visits, testing, and inspections. Moisture management is integral to the success of mass timber installation. We see here collaborative feedback received from the contractor, RDH, and our mass timber manufacturer. This simplicity of form and the nature of mass timber required fewer thermal bridge models because of the reduced overall issue on the enclosure. RDH made recommendations for the insulated window frame and in sequencing the weather-resistant membrane. The thermal bridge modeling ensures a sufficient U value for the installed frame. If this is your first time seeing a thermal bridge-free diagram, it is ideal to have this continuous thick green band on the enclosure, which was achieved by pulling up the sill and introducing that green highlighted piece of insulation on the sill plate. On site, this typical window detail accounted for sequencing of trades and the construction schedule. The image on the right here, we see the rough opening being prepared to adhere the membrane. An additional membrane is loose laid over the sill in preparation for the sill insulation. Once installed, the release film is removed and draped over, and it's not necessarily adhered, but substantially, but is more in place to wick water away from the sill edge. As Morgan had mentioned before, we made keystone decisions around the building envelope and mechanical systems early during design development and thoroughly reviewed submittals to review variables impacting our passive house planning package. RDH's submittal review list on the left was one of our pre-construction meetings. It underscored everyone's roles and responsibilities for certification. This included the contractor, consultants, and building system trades. And just for some perspective, that before we go into construction, we're submitting our passive house planning package to our certifier for review. And then once that has been green lighted, then we go into construction, where the role of the contractor is mainly to document the process so that what we proposed in the energy model matches what is being installed in situ. And then with that, then we have testing that will contribute towards that final certification process. So well in advance of construction, we were vetting these mission critical passive house components. A year ahead of construction, the process led to an expedited submittal review during CA and ease of component tracking and integration. For example, to swiftly coordinate the ERV submittals, it was first reviewed by the mechanical trade, passed along to the contractor, then architect, engineer, and finally our external passive house consultant for review and approval. So having covered these passive house design principles, I'll now delve into this layered approach for collaboration in mass timber whilst targeting certification. Affordable housing is at the forefront of this design build payoff diagram. It's a multi-factor matrix of choices. In the rows, we have a risk scale, and in the column, choices in design decisions. Our approach in incorporating passive house design sought for opportunities to de-risk building performance uncertainties early on. The impact of this method reduced variables such as costly changes on site and aids in navigating an accelerated timeline. These are energy conservation measures, or ECMs, proposed by RDH in targeting our Passive House certification. It is color-coded in ease of implementation and identified through the impact on our overall space heating demand. In green, we have recommendations for windows and door improvements. ECMD, for example, reduces roof penetrations in half and have a significant impact on achieving our performance target. ECMH was a little bit more challenging, however, where we were proposing to reduce the ventilation margin for assumed air leakage. Proposed by our mechanical trade, their team built a 1-to-1 scale duct leakage mock-up within their shop. This was an example of a belt and suspenders approach and captures the collaborative spirit they brought to the project. The ventilation tested for best case to worst case scenarios, and testing gave the trade pause to re-examine our assumptions on their install performance. So in the end, we carried a more conservative margin, targeting additional ECMs to achieve our performance target. We attribute our team's agility to efficient biweekly meetings. Hosted by the architecture team during design, responsibilities shift to the contractor during construction. It sets the pace for projects on an accelerated schedule and for quality assurance. Here's a trailer meeting reviewing the enclosure process. In advance of installing the roof and cladding system, we received input from trades, including cladding and roofers, the supplier, as well as a team of consultants such as our mechanical and electrical. The payoff is mitigating risk in construction that deviates from the Passive House design. At time of delivery, the contractor is testing for 10 to 12% moisture content. Once installed, the splines are being tested to confirm a moisture content of no more than 16%. These connections between the mass timber panels are much more prone to absorb water. The team has undertaken moisture monitoring at these locations to see if we have elevated moisture levels. And daily site monitoring was supplemented with periodic testing ahead of the floor topping pour. And so this is really when the moisture management plan came into place. It was unexpected, but there was a lot of heavy rainfall at the end of July and early August. And because we had that plan in place, everybody knew about their roles and responsibilities, and we were able to navigate this instead of the consequence, which would be not knowing what's going to happen and trapping moisture into the panels after the floor topping was put on. A mid-construction whole building air tightness test is crucial in identifying and addressing air leakage issues early on. RDH conducted a test once the installation of our exterior weather-resistant membrane was complete. This was one of our more challenging energy conservation measures to implement, and beyond that, we had an ambitious target of 0.4 air changes per hour at 50 pascals, well below the certification requirement of 0.6. These images were provided by our building enclosure consultant, Ben Brown, from past projects he was working on. It highlights the importance of leaving the air barrier exposed during the mid-construction test. These images are from a test in which cladding clips and insulation were already installed. After failing their air tightness test, their team pulled back the insulation. As you can see, smoke is only visible once the air barrier is exposed. In this case, the cladding clips were removed and installed elsewhere, leaving unsealed screw holes and many penetrations through the airtight control layer, which had to be mitigated before reinstalling their insulation. The mid-September marked a milestone achievement. Our airtight layer was complete and ready for this mid-construction test. For 1620 Main Street East, this mid-construction whole building air tightness test results were a huge success, achieving 0.08 air changes per hour at 50 pascals. The temporary ceiling is included in the blower door, and the mechanical ducting is open to the exterior. That's the image on the right-hand side. So as Morgan had mentioned before, current progress on site shows the rewards of prefabrication. Through these bi-weekly site visits, we witnessed the rapid pace of the CLT installation. And once the mid-construction air tightness test was complete, installation of the thermal bridge-free cladding clips followed suit. Our latest site visit, outboard installation is nearing completion and cladding installation is in progress. This month, we're anticipating our final air tightness test, and that will contribute to finalizing certification. 1620 Main Street East affordable housing highlights this critical role of recurring partnerships to create accessible, safe, and inclusive housing solutions. The evolution to mass timber passive house underscores the importance of this collaboration and integration. Our solutions thus far have been to communicate early on and often, and to de-risk building performance uncertainties through early design decisions. At each iteration, we incorporate lessons learned and pull new levers to evolve to the next prototype. So I'm going to hand it off to Matt to talk about what are our future opportunities.
Great. Okay, thank you, Christina and Morgan. I couldn't have done that, so thank you. That was really great. Future opportunities. So as we were saying, we have been working over this time with some really great people, and that should be understated. And those people are builders, trades, consultants. Even again, we've had a very supportive one of the great things when you're working in this housing continuum, and specifically, we're at a time of crisis of a shortage of housing. We're at a time when a lot of even what are typically, especially to us as architects, seen as the enemy or on the other side of the fence in terms of approvals authorities, whether you want to talk about the site plan approval process or the building permit process. I mean, I think what the last number of years and that crisis of housing has created, both functionally in terms of the subsidy models that a lot of the jurisdictions are facing, as well as just everyone's bought in understanding of the need, is it creates great collaboration. So again, we've really tried to be leveraging that. What I want to go through here is some of the projects that some of this work, the early work that we've done that we've featured here today has been leading to through the collaborative nature of how we like to approach things. So this, we're working with N's design office. Jonathan N's really brilliant architect who's not only worked in practice, but also worked in the educational fields of architecture, but is also now living up in this place, him and his wife. They've been this great resource of understanding for some of the even more amplified issues they have with housing and housing supply in the north, in remote communities generally in the northern part of Canada. So we've been able to work with them, apply some of the things we've been doing to this particular building. Is a low barrier shelter, as well as a single resident occupant transitional housing unit. So combine in a mix of uses within that housing continuum of need. And this has been a really great project to work on. There's been lots of feedbacks, lots of different paradigm shifts that we don't have to deal with here, such as obviously you're dealing with permafrost, you're dealing with not wanting to use foundations that dig into the ground, having to elevate everything above. You also have just logistical items like elevators and the challenges that a lot of groups have in having their elevators serviced. For us, created this opportunity to do what would be typically unconventional in housing, of giving up the amount of common space we have here for a ramping element to create accessibility within the building, but also have that double used as a connective tissue and almost a public space, internal public space to what although the rendering we're showing in the middle of summer when the sun's up for 17 or 18 hours a day or more, in the winter where I have been there, it's a much different and much more inhospitable climate. So working with them, that's been really great. This project hasn't gone fully mass timber. I mean, that's the practicalities of that. Again, we've had to evaluate, aren't necessarily there, but in the case of the ramping element, that actually was an area where it made a lot of sense to do that. So again, that's been interesting. Further, to the work we've talked about today, particularly what Morgan was featuring as part of the rapid housing, where it's made a lot of sense in that rapid housing delivery to use full mass timber kits of walls and floors. We've seen other applications for affordable housing and even for market housing that hasn't necessarily made the same sense. And we've had to try to figure out how can we pick up every efficiency we can on this delivery. And so we've been working with some great people in that space as well. In this case, it's a project for a six-story affordable housing project geared towards seniors. It's working with a church along with a development consultant with a lot of practical knowledge of market rate and affordable housing delivery. And in this case, we've actually worked with them on coming up with a panelized hybrid solution of stick frame walls that actually in some cases allow us to get more and better insulation values in our exteriors, and also obviously reduce costs by having, maintaining a lot of the rapid delivery, but again, in a slightly different construction management delivery in this case, that just works a little bit better based again on the needs. Again, some more work in the north. This is a mix of uses for a makerspace and just really trying to drive. This is still in early stages, but again, really some exciting work that we're doing that's leveraging some of this knowledge and understanding that we've built now as an organization and through our partnerships. This is one that's, and there's a series of projects that are largely being initiated out of our Hamilton office that not only push the boundaries of what we're doing in mass timber, with this being an 8-story, obviously over that 6-story threshold that's been there and moving into what the now new code updates are permitting for. So not only pushing that and leveraging that knowledge, but also coupling in adaptive reuse and heritage understanding, which we've done a lot of work of. We showed that the Glovebot project at the beginning, as well as various others that we've worked with at the office. So being able to flex our muscles there in terms of community engagement and understanding and adapting to the place, but then also working within an integrated project delivery model for this particular project. And that has and a series of other projects where the client group and the various collaborators on the project, that there was buy-in, there was understanding, and there was belief that it was going to be the best system and delivery method. And so again, for us, we're learning lots about that process as we've gone through it and are delivering projects in that methodology. I think the key thing is whether you've changed your place where you're working, the climatic issues and data, or the contractual data and issues, it's good to have that toolkit of solutions that you can bring to the table, and they all require that collaborative mindset. But we've become well versed in all of them. So everything from that fixed price stip sum, the most sort of straightforward and basic, to the obviously much more common now construction management, either in a 5A or 5B, and then we've again done. It's not a fully contractual architect-led design build, but we do feel much more empowered in the CCDC 14 that we've done on the rapid delivery than in other cases, just because the builder and the groups who we're aligning with really want and need our leadership in those projects. So we've done them, and then again to this type of IPD project. Another thing we're really interested and excited about, and again just across building out that missing middle portion of the housing continuum and just coming up with adaptable solutions. Of course, a lot of you know that, again, at a legislative level, both federally and provincially, there's been a big push to take what is our existing stock of single-family homes and figuring out ways that we can densify and intensify those, so that every project can't necessarily be a 4 or a 6 or an 8 or a 12 or 40-story residential apartment building. We need to look for other ways to add that sort of density and do it with innovation and panelization and some of these things. So we've been very fortunate to be able to work again with some really great collaborators on developing what is essentially a stacked town design, something that can be repeatable and stacked up against each other, but deploying it in some cases on this given site in Kitchener. It was a site that had a very small burnt down house. The city of Kitchener had taken the lead in pushing their 4-unit per lot zoning, which created an opening for us with again a motivated client and a really great build team and consultant team to actually come up with this first single stack of 4 units that work. Again, we're using a hybrid, totally panelized system, but the hybridization is that we're using the CLT floors, and in which case we've also been looking at NLT and DLT, which are other obviously mass timber style slab-based floor systems. And what that's really great for on this type of a transitional density of housing, it's not low-rise single-family home or townhouses where you don't have any horizontal fire separations. You have those, you have to manage them on this type of a project. So to be able to do that with using those CLT slabs, but then not have to be overly cumbersome in terms of the wall and keep things more conventionally minded and understood with the wall systems, has been a really interesting and exciting and dynamic process that we've been working on. Again, very, very much the contractual methods for these types of buildings and these scale of buildings is much more streamlined, but it's still the ultimate same process, getting around the table, meeting on site, and just engaging in that process. So this is a site where the entire building, again, got delivered to site, all panelized, including walls, exterior walls, interior walls, and floors, and erected up, as you can see here. So that's something we're very interested and exciting in leveraging as a different, and again, another tool in our toolkit of typologies. And finally, we're really excited to kick off this year. And some of you, again, depending on where I may have heard about the Build Now initiative that's happening locally. There's other, similar initiatives that are happening through other jurisdictions, we're sure, but this one is something that has been in the news of late for the city of Waterloo, basically working with a group led by Habitat for Humanity, but also a lot of community-based development experts, construction experts, and again, design and consultants to work up how we can deliver 1,000 homes plus on this site in Waterloo, a vacant land parcel. So we've been very fortunate to be involved in some of those early discussions. We're continuing our work there, again, in a collaborative way with the design community, both locally and abroad. And again, just really excited about what that's going to create for not just for us and our portfolio, but also for the industry, for the housing continuum, and the way we're hopefully going to be able to take these different typologies, these different methods of executing sustainability and high performance design, mass timber, and other methods, bring them together into one place where we can really leverage those and have them start to work together in an eclectic way, but also in a very sustainable and well thought out. So we're just over the hour mark. I know that was a lot of content. Hopefully it was digestible for everyone. We didn't want to over program or slam too much in, so we have tried to create a bit of a buffer here where we can do some Q&A. Haven't looked too much through the Q&A myself, actually, but I might, Claire, I don't know if we want to hand it off to yourself or Ashley to take the lead, but that's where we are for now. And thanks again, everyone, for attending and for giving us this privilege of being able to speak here today.
Yeah, we don't have any questions in our Q&A yet, so I really want to encourage those in attendance today to submit those. We do have a couple of questions. I think Ashley's got 1 or 2 questions for you. So while you answer those, anybody on the call, please, again, at the bottom of your screen, you'll see a Q&A with a little question mark. Just click on that and you can type in your question for Matt, Christina, and Morgan.
Okay, so my question for you all is, what detailed aspects of the project were most influenced by passive house design and constructing in mass timber?
Well, I'm going to, that's obviously it's a 2-parter. So I'm going to defer that one to, again, what we've already established here, are our experts. So I think that the passive house aspects was maybe the first part. So we can go backwards up through the order of presentation, and I'll hand it to Christina, who then can pass it on to Morgan.
Gosh, I was hoping Morgan would start, but
Okay,
Yeah,
well.
can you just say the question one more time, and then maybe I can try to answer it?
You're on mute, Ashley, if you want to unmute yourself.
Sorry, 1 second, because I lost the question.
There was a lot of content in there.
I know. 1 second. Here it is. Okay. What detailed aspects of the project were most influenced by passive house design and constructing in mass timber?
Okay, so yeah, maybe I'll start with the passive house one first and then move to mass timber. So I think, or maybe it's easier to start with mass timber. I think, as we kind of mentioned earlier in the presentation, using mass timber obviously drives, and again, this being a fast-tracked, affordable project, really drives like the size of panel and making sure that we're being as efficient as we can with the material we're using. And again, working with our local manufacturer, just making sure that all of those, structural spans and bays are as efficient as possible, and we're using as little waste as possible. So that really derives the span sizing and again, just some of those overall dimensions. And even how in a lot of our projects, we've really tried to put our exit stairwell and kind of roof access on the side. That's always kind of, to keep, again, that grid sizing and those bays and the amount of kind of crane picks to pick up those CLT panels to the smallest amount possible. And then in terms of passive house, again, this being affordable and a very efficient, economical design, really focusing on those critical junction points and thermal bridging and those important cross sections and trying to just reduce the amount of detailing by doing one detail really well. Again, Christina talked a lot about that window detail, and that was so critical that created most of the thermal bridging in this project. So trying to just pick these really well designed moments and then having those kind of executed across the project and not having a ton of different junction points, but really doing a few things very, very well. I don't know if anyone else wants to kind of jump in and add anything.
Yeah, if I can just add some of those detailed aspects, Morgan, you had already highlighted in your schedule that by the time there was that charrette during the RFP process, we were identifying key mechanical ventilation components so that we're able to understand our heating, space heating demands. And then again, with the windows, there's a bunch of suppliers now in North America. So there's been ease in doing that. And with that typical wall assembly, the more that I dig into cladding clips, it seems to be very typical that you can have these 8-inch outboard cladding clips that are sufficient and now typical in the industry, that it's really not going to make you have to overhaul the exterior envelope. So yeah, I would say just the choice in different components.
Great, I see we've got a bunch of good questions coming in. So I don't know who wants to take these, if there's anything that
Did I just kind of roll down the list top to bottom?
yeah, I think the first
so-
one, yeah, I know you've answered one already, Matt.
Yeah, also I'll just speak to it because I was typing away there as the
Yeah.
other two were doing it. So yeah, there was a
Alright.
question was around sound and fire in mass timber, which is a great question. Interestingly enough, and we didn't get into it in detail, fire is something that was a big driver, I'd say 10 years ago or even 5 years ago, when building authorities and just generally there was a lack of understanding of okay, mass timber doesn't burn. It actually it chars and then it doesn't burn through the way that stick frame wood and obviously we can go back to that campfire log analogy. If you put little sticks and kindling on a campfire, very easy to light it up and it'll burn through, versus if you just put a campfire log on the fire and then try to hold a lighter to it, it's not going to go up. It's just going to char on the outside. And that's the same technology. The testing, the data, it's been now hardwired through our great code consultants into the building code. So all of that from the fire side is pretty straightforward. We can, in a lot of cases, in up to the 6-story, expose our mass timber. Usually to get that 1 hour fire rating can be done with a 5-ply, 175 millimeter, roughly 8-inch panel, which all is nice because it all syncs up similarly dimensionally with what you see in other forms of construction, be it precast or what have you. So that's all. The fire thing is pretty straightforward. Again, there's even, fire stopping, penetration sort of details, donuts, and different things that are all out there that are all applicable, and we've been able to leverage and use all of them, all to great success. Acoustics in the last years, as we've been working on some of these projects, has actually been a bit of a bigger challenge, because there, again, of a lack of data. There actually was a lot and a big amount of testing data done on fire, but less so on acoustics. We've been working, again, over the years on every one of these projects to gain and build more testing data out in the field, because that's where it really becomes important, both for approvals. Generally speaking, a lot of jurisdictions will take a letter from either the architect and or an acoustical consultant as saying, yes, this meets the ASTC rating required by the code. That isn't something that the city always needs to see in terms of testing data, because of the nature of it. They're usually just willing to take the word of and the sign off of the expert consultants. So for us, and for the end users, we've been really trying to drill down on making sure that those details of how we're soundproofing our assemblies are being done effectively, and then testing to make sure that they're actually functioning the way that we intend. On that note, I would say that we really have two types of toppings, and most of the acoustical attenuation we're doing at floor levels are done with a topping versus anything on the underside. The underside we can keep exposed for fire, and we like to, and that's where you get the biggest, that sense of warmth and well-being and all those biophilic advantages that come with mass timber. Those are oftentimes best felt in that ceiling, the soffit condition, and experiencing it that way. So much of what you see in residential, the exposure of the top side of the panel as flooring, everyone wants a different flooring preference, and also just the nature of construction. It's not really reasonable or feasible through the detailing to expose the top surface of a CLT panel. We're always covering it up anyways. So what we've now come to is basically two different types of systems. There's a wet applied system, similar to what you'd see in a precast panel delivery, where the panels come in and then there's a slurry, a topping of 1.5 to 2 inches put over top of it. In the case of our when we call that our wet topping, in a lot of cases when we're doing a wet topping, it needs to come with a decoupling membrane on top of the CLT. So we've spec that and used this in a number of different locations and tested in a number of different locations now. We are working also on dry applied systems, and there's a pretty robust network, as most of the architects will know, for acoustic suppliers of products and innovative products, and a lot of testing happening there. And so we are currently working and have been doing conversational work and testing even with some of those organizations, and have now started to spec a dry applied system where it comes in either a roll or a panel based form, usually with an overlapping and multi-layering that can in some cases either save on time and or cost. So we're just always looking to try and work with our construction teams to balance those factors and make the best decision. But the more we're doing, the more we all are doing collectively, as a profession and as a building industry, the more data and the more products we're going to be able to have utilization to. So
there's a question here that's a good segue into what you were just discussing, Matt. Have there been any challenges with building inspectors and new construction methods with rapid schedules?
Maybe I can jump in. I think what's critical about these projects is aligning yourselves with the authority having jurisdiction. On a lot of the projects we talked about today, especially the ones using new methods in the mass timber field, I think it was critical that right off the bat we got in touch with the city, our contacts there, and offered a really open, collaborative conversation with them to ask questions and kind of get on the same page. With the YW projects in Kitchener, because of the CMHC rapid funding was coming directly through the city of Kitchener. Essentially, they got the funds and then we're allocating them to the groups who they deemed who got the awards, like the grant money. So for them, they implemented a kind of a project manager on their side, which was really helpful because we were able to work directly with that internal project manager, and they were able to help kind of streamline, getting our permits, getting in touch with people. There definitely has been questions on site, but I think just understanding the code, of course, and then being able to back up all your information and have that again, that open dialogue with the city. So when they are concerned or they have questions, it's really easy to sit down and just talk them out. And when you do need to go get kind of external advice, having, you know, your code consultant, either internal or external, be able to help you kind of work through that.
Here's another question. Were there any surprises with using CLT coordination-wise that weren't initially understood until being well underway into this project? For example, electrical wiring.
Yeah, go ahead, Matt.
Yeah, well, I was just gonna, there was two that come up. Wiring we hear about a lot. In the case, it should be noted too, when we were talking about fire, and even when we're talking about hybrid systems where we're using those stick frame walls, in a lot of cases, almost all cases, even if we are in the mass timber wall panels, we're still oftentimes covering them up. And that's for twofold. One, we only need a 3-ply panel in a lot of cases for our bearing walls, unless there's sort of outlier specific shear requirements or some other. But generally speaking, our structural walls, we can use a thinner panel. That thinner panel then doesn't give us the 1-hour rating we need, so we need to laminate something onto it in the form of drywall in order to bump up that rating. And in addition to that, there's so much services and things that go through our given walls, be it electrical, be it plumbing, be it all these other things, that we've just found that there's more value in covering it up than there is keeping it exposed. We did on our very first project keep some portions of the exterior wall exposed. And what we also found is, you know, you go up and as beautiful as CLT and this mass timber is, it does crack and check over time, just like any, you know, product. Once it gets into that treated, heated environment, you're going to see it. And so, you know, you imagine a kid running their hand down it or something like that, you know, could be a splinter or could be this or a little crack. So again, we find that in the application of an exposed ceiling, it's ideal because you're not having that tactility to it. And on the ceiling, for the most part, we can deal with very, very minor mechanical and electrical, like maybe there's a bit of conduit, or you know, there are ways that we can do a little bit of CNC routering, maybe to a light switch or something like that. Also, certain areas we drop a ceiling on anyways in either washrooms or sometimes over kitchens in smaller areas. So again, we've just tried to electrical. We haven't had that much of an issue. Coordination wise, it's sort of easy. And to that, I just wanted to, you know, there was an anecdotal on one of our first projects where there was a roof drain in the wrong location. And we were sort of standing around, you know, scratching our heads, well, what do we do? And, you know, I sort of looked to the side, said, anybody have a hole saw? And you're done, right? So, I mean, the idea is that in the event, I mean, there is a huge amount of precision that we can do through the manufacturing, the offsite manufacturing that Morgan spoke to. There's a huge amount of precision we can get there in that everything is coordinated and every opening, every penetration, and we do, because there's time savings value to it. That being said, if there are anything, even a change, you can imagine sometimes, you know, an owner might come into a site and say, I need this here. It's very, very easy to do and to handle. And that's where even dealing with our trades, even though there's sometimes fear of the unknown, generally speaking, after you get a trades involved and experienced in this type of a system, they tend to really like it and really enjoy, you know, not having to core through a precast panel that they have to scan for rebar and do all those things. It's a much, in that case, simpler process. So yeah.
I do want to touch on, I see the question here, how detailed was the design charrette for the contractor to be able to provide a valid fixed price? Did the project experience cost uncertainty after fixed price was established when more details were finalized? So maybe I can talk a little bit about that, because I think it's really interesting. As I mentioned, we have worked with this group, specifically the one specific contractor in these kind of 3 or 4 projects, I guess 4 projects. And so that, you know, there was a lot of comfort in reference projects. So obviously for 1620, the uncertainty was the passive house components, but we had done, you know, block line 1 and block line 2 and a project in East Gwillimbury that were all very similar. And so they had a pretty decent database of information to pull from. So we did kind of, it was at, I guess, 100% SD, maybe a little more than 100% SD. And again, we had the weigh-in already and the vetting from the mechanical contractor, who obviously that's a big ticket item. The passive house consultant, again, as Christina mentioned, we fully committed to a building envelope system. The mass timber supplier, they provided, again, a price. And then we, the RFP finished, we provided the fixed price contract. There was like a little bit of kind of horse trading with the client. There were some changes that they wanted to the design. I think that we had a couple options presented. They were uncertain about if they wanted to do a 4-story or a 6-story. So there was like a little bit of a period after we had won the RFP to kind of flush those decisions out and then make the fixed price. But I would say they were pretty like they were confident, and again, just having that line in the sand that this is what the fixed price was and how much variation we could stray from it. And again, there's obviously project uncertainties, and that's why you have a CCDC contract, which does kind of outline what happens when there is kind of changes that come up in construction. But I would say for the most part, everyone again is aligned on the goal of the project, and there's not like too much straying from that initial fixed price.
I think that's a good segue into this other question. Can you please expand on the funding you talked about? What was the funding program specifically for, and was it easy to apply for? So kind of bridging those two questions together, because we are prototyping these buildings and we have a pretty fast feedback loop, and we're working with similar team members from one project to the next. There was a feasibility study that Matt and we were working on last week, where we were able to take Class A costing information from 1620 and be able to apply it to a similar project, so that they are able to with confidence pursue funding and not be going over like their higher end limitations. The funding programs, it's through CMHC, the Rapid Housing Initiative. There's a few different phases that have been launched Canada-wide. Matt, maybe you can speak a little bit more to those funding opportunities.
Yeah, for projects specifically, CMHC right now, if you have elements of affordability for purpose-built rental, if you have elements of affordability, energy performance, and accessibility, that's where CMHC, and it's either has programs that are geared towards providing all three to a certain minimum bar, or one or the other to a really substantial level. All of those programs are out there. A lot of that programming has changed. We expect, honestly, in the horizon of a potential government change at the federal level, that could change again, given that CMHC is obviously a federally run organization. So there's lots of programs out there. I don't think we can speak. I mean, we are in the process right now of we've worked with them and in our work in the housing continuum, again, particularly from that supportive housing, affordable housing, and purpose-built rental. We've been working in that space for a number of years, but again, there is a lot of movement and change that's always happening there. So I would suggest, again, doing as much reading as you can, having as much discussions as you can, either directly with CMHC or with other consultants and other groups who are working and living in the space, because it is just a constantly moving target for us. Accessibility is one that we have tried to put a lot of focus on as maybe a third part to this discussion that we could have expanded into, would be accessibility, and with the Rick Hansen certification program now, of which we're really integrally getting involved in, in terms of that whole element of inclusivity in housing, we are working there, and we see that as a really positive thing that's happening in that space right now. So I wanted to, just when it came to cost and affordability, there was something before we touch on the IPD one that came up about precast versus CLT, and it was a really great question. I just wanted to touch on it quickly, because when we first started, when we got that first project realized, what we had to do is take that conventional, and the conventional for these types of buildings to that point, largely, whether you had a masonry block or a total precast or an ICF or what have you, they all had one thing in common, which was a hollow core plank floor system. And of course, as we know, there's limitations and optimizations to what those hollow core planks can be and how they can run. One thing that is consistent, though, is they're always 4 feet wide. And that was what we took as our opportunity. So what we said is we understood the manufacturing restraints that various different providers had. Specifically, because we had such a relationship with Element 5, we really drilled down on what were their limitations on manufacturing, transportation, what have you. And what we found is, from a length standpoint, there were similar capabilities, both in terms of shipping dimensions. And as you know, most 52 feet being what can fit on a long bed truck. That's sort of where you're capped on your length, but also in terms of bearing points. For a precast panel, there's only 2 points of bearing, simple span at each end. And so then there's that camber between, and there's an optimized, an 8-inch panel can get you this far, a 10-inch this far, or what have you. We understood those, so did our buildings, because our buildings were built with bearing walls that sort of synced up with those. So what we did as we were starting to develop our mass timber, we tried to sync those up in the similar way as best we could, so that it was an apples to apples comparison of, you didn't have to redesign the building to optimize it for CLT. We could create similar solutions in terms of building layout and structural layout. The one change, though, was that in a mass timber application, it's actually beneficial, and you can thin up your panel's thickness if you have multiple points of bearing, so continuous bearing. So if you have a panel that's spanning across and there's points of bearing in between, that actually benefits you. And so we were able to leverage that particular point to thin up our panels and have a similar then thickness relative to span in terms of the picks off of a truck. But we also were able to take advantage of the fact that our CLT panels, because of their lightweight nature and manufacturing tolerances, could go about 2.5 times wider than that 4-foot precast panel. And that was one of the big, especially in the early days, especially when we were starting, and there was even a sort of a supply particular issue when there was all those supply chain issues. There was that opportunity to leverage that argument and sell and use it as that opportunity. And so since then, we've obviously been working in a similar way to try to show those advantages or kind of differences in the two product limitations. But that was an answer there. I just on the IPD side, I don't. The three of us on this call aren't actively working in an IPD. We have a couple members of our team who could speak at length with you about that process and the good and the bad and all the other things. But I think what's really clear through our discussions and all the feedback loops we've been getting, particularly with IPD, is having the people on the team who are not only bought into it, bought into the delivery of it and understand it conceptually for what it is, which is a sort of bought in, shared risk, shared reward. So that's number one, is you have to have that. But that, I would say, isn't even enough. You also need to have the insured capability and experience to deliver. Because if you have someone who has the best of intentions, but ultimately can't deliver, whether it be a trade or anyone, then that really is problematic and challenging to that process of shared risk, shared reward. So I think it's a really great thing if you have that right team who again has that confidence. But that would be something definitely to be cautious of, and maybe even look to use other delivery methods in advance of going to the IPD on maybe an introductory project to build the confidence, and then look to leverage the IPD after, would be probably what we'd be discussing with a lot of our clients and opportunities now moving forward. But great system, obviously.
And I would just jump into and say that on these projects, though we kind of aspired to some type of IPD, we wanted everyone to be incorporated. At the end of the day, given like the fast track nature of these, it really didn't make sense on these projects. And again, like with our expertise and having, a general contractor who's really competent and can kind of at the end of the day make those executive decisions, again, I think is really important on some of these projects, because our contractor is able to say, like, no, we're the ones kind of holding the purse strings, we're managing the budget. We will be kind of, doing a certain way. And again, they're very collaborative and open, but again, on some of these projects, I don't think going with IPD was the right move. I would say in some of the next iterations, now that we've kind of have this background knowledge and this confidence and collaborative relationship with these teams, that could be a next step or that next lever to pull on.
And just to answer the last question we have here, I know we're at our cap, but I'll just say that integrated IPD is a defined contractual type. It is now there. It is referenceable, although it's not. A lot of people aren't that familiar with it, which is why another reason we needed simple and well understood construction contracts to work with the rapid housing initiative funding stream. So we couldn't use the IPD. It was just too known and unknown. But IPD is that defined contractual type. Your question about the IDP, I won't speak to it. I'm not sure. It could just be something similar that gets characterized a different way. It could be another defined term, but to my knowledge, it's not a defined Canadian construction contract type, which IPD is.
Great. Thank you so much. Thank you, Matt, Morgan, and Christina. This was a wonderful webinar. We're right at time, actually 1 minute over. But thank you so much for everyone on the call who attended and for the great questions.